The last thing that we're going to be doing is graphing linear functions. There's a couple different forms that are helpful. Slope-intercept form is very easy to graph from. Also, standard form is very easy to graph from. If you're given a point and a slope, we've already graphed from that earlier in this lesson. So these are the two forms that we haven't quite graphed from. If you're graphing from slope-intercept form, first thing I want you to do is identify your slope and the y-intercept. Once you have a slope and a y-intercept, I want you to plot your y-intercept. Your y-intercept will be the point 0, b. And you can find another point by using your slope. Or I want you to think rise over the run. Don't forget to connect your points using arrows. This graphing should be similar to the other graphing we did earlier when you were given a point and a slope. In this case, the point is just more specifically the y-intercept point. The other types of problems what we'll be dealing with is graphing from standard form. So one thing that you could do is you could translate the equation into slope-intercept form and then repeat the steps above. Or there's another way of doing it. We could find and plot the x-intercept by setting y equal to 0. And that point always looks like some number, 0. Then you can find and plot the y-intercept by setting x equal to 0. And that point always looks like 0, some number. And then connect your points using arrows. On standard form, I'm going to be focusing in on the new steps, because on the first method you can just translate into slope-intercept form and you've already repeating the steps we've done before. Both methods are valid though. Looking at our first problem, y equals negative 3x plus 2, I can tell that that's in slope-intercept form, y equals mx plus b. So my m, or slope, is negative 3, and my b is 2. Or another way of thinking about that as a y-intercept is 0, 2. So now that I've gotten my information, my slope and my y-intercept, all I have to do is plot the point and then use the slope like I did earlier. My point is 0, 2. My slope is negative 3. Another way of thinking about my slope of negative 3 is negative 3 over 1. So I can use negative 3 as my rise and positive 1 as my run. You always have to have both a rise and a run. So my negative 3, I'm going down 1, 2, 3, and right 1. Let's repeat, down 1, 2, 3, and right 1. The other thing I could do is I could go up 1, 2, 3, and left 1 following my pattern. Notice that all of those points are collinear, meaning they lie on the same line. My next equation, y equals 3/4 x minus 3, is also in slope-intercept form, where my slope is 3/4, which is already a fraction, and my y-intercept, or b, is negative 3. Another way of writing that would be 0, negative 3. First, I'm going to plot my point before I use my slope. So my point is at 0, negative 3. And then my slope says 3/4. So my 3 is my rise, my 4 is my run. So from my point, I go up 1, 2, 3, and right 1, 2, 3, 4. Notice this will give you a positive slope. The other thing I could do is I could go down 3 and left 4, which will still be on the same line, or what we call collinear. Draw the longest line you can and don't forget to put your arrows. The last two problems are in standard form, which is ax plus by equals c. So because I'm in standard form, I could either solve for y and put it in slope-intercept form, or I could try to find the x and y-intercepts, which is what I'm going to be focusing on here. If you are trying to find the x-intercept, you're going to take the y value and set it equal to 0, which gets me 6x minus 9 times 0 equals 18. well, 9 times 0 is just 0. So I have 6x equals 18. And then I can solve that fairly quickly and get x equals 3. Although there's an even easier method, and I call this the cover-up method. It's a little bit hard for me to do on video, but I'm going to do my best here. If you're plugging in 0 for y, notice that negative 9 times 0 made it go away altogether. So instead of actually writing out all this information, what you could do is you could put your finger and cover up the negative 9y, because negative 9 times 0 is negative 9. Now I don't have I can't put a finger here, so I'm just going to cross it out and then I'm going to come back and erase it. Please don't cross this out because I know you're not going to be able to see it. But if you essentially put a finger on it, then you can only see 6x equals 18. Can you divide and solve in your head to get 3? And I think most people probably can do that. So that's the cover-up method. You cover up the value that you're plugging in for 0, and then you solve the rest. So let's try that cover-up method again with y-intercept. In this case, for the y-intercept, I need to plug in 0 for x. So I would like you to put your finger over this 6 times x, because 6 times 0 is just going to be 0. Again, I'm just crossing it out. I'm going to erase it, so don't do it on your own. Just put your finger over it. And now you have negative 9y equals 18. Can you solve that? Sure, just divide both sides by negative 9 and you're getting negative 2. I'm going to go ahead and erase that because I don't want people to get confused when they come back and look at that. So I have 2 points here. The x-intercept 3, 0, and the y-intercept 0, negative 2. 2 points is good enough to give me a line. And I have graphed my equation in standard form using x and y intercepts. Again, using x and y intercepts here because I'm in standard form. If I want to find the x-intercept, I plug in 0 for y, or essentially cover up y with your finger. I'm left with 4x equals 6, so divide both sides by 4. Some of you could probably do that in your head. And I get 3/2. I'm going to go ahead and erase that. If you're having a hard time with it, you're always welcome just to write it out to the side. 4x plus y, which is 0. 4x equals 6. Divide by 4. And x is still equal to 3/2. I just find that some students prefer to use the cover-up method because it is quite fast. For my y-intercept, if I plug 0 in for x, one way of doing that is just to plug in, cover up your finger on x, and then I'm left with y equals 6. Well, there's nothing even to solve there. I'm just left with y equals 6. You can take your finger off, and I have 2 points. 0, 6 is right here, and 3/2, 0. 3/2 in mixed form is 1.5. 0, which means that you need to lie between 1 and 2. Now, if you're off a little bit, that's probably okay, but you do need to make sure that you're between at least the correct 2 numbers. Connect your points with a line. Don't forget your arrows. Now, if you don't like using a fraction, you're always welcome to get another point by just picking another point and plotting it, and then you can get a much more accurate graph, and that's also okay with me. Well, this concludes our lesson on linear functions and their slope. We've talked about the 3 different forms: standard form, slope-intercept, and point-slope form, and when we use them. We talked a lot about slope and the formulas for slope and graphing using slope. We wrote equations of linear functions using a point and a slope, our special cases, and using Hoy-Vux, or writing equations from 2 points, and writing equations using parallel and perpendicular slopes and the information you got there. And finally, we finished up with graphing linear functions using slope-intercept form or standard form.